guys, we're going to get started here by looking at the law of sines. So this last unit is going to be looking at a few other topics in trigonometry that we have not touched on just yet. So we'll finish this up and then you'll be off to college. All right, so the law of sines. My hope is that you experienced some of this in your geometry class a few years ago, but if not, no worries. We got time to practice during this year. So we're going to look at triangles that are not right triangles, all right? And these are called oblique triangles, all right? So our triangles that we'll be working on in this unit will not be right triangles. So really, I'm talking about three specific types: angle, side, angle triangles, where we know the measurements of two angles and the included side. That's probably the most common time we use the law of sines. Then angle, angle, side. We know the measure of two angles and a side, but it's just not between the angles that we know. And then side, side, angle, we know the measurements of two sides and an angle that's not between the no sides. So essentially, the way you're going to see in this lesson and the next lesson is you're going to always try to do the law of sines. It's a little bit simpler than what we're going to do in our next lesson. But if you can't use the law of sines, that's when you enter the law of cosines. So we're talking about that next. So here is the law of sines. All right, I'm going to use this version of it. You're more than welcome to use this one where the angles are in the denominator. It really doesn't matter as long as you keep them the same. So if you decide to put the angles in the numerator or the angle in the numerator on the left side of your equation, make sure that's also true on the right side of the equation. Okay, so let's try to do one here first. And I know they use alpha, beta, and gamma. I'm just going to use A, B, and C. And kind of your takeaway here should be the capital letters. So capital letters are angles and lowercase letters are side lengths. Okay, so this is going to be side length A. So we know two angles. And the first thing I do, if I know two angles, and you guys learn this in geometry, if you know any 2 out of 3 angles in a triangle, you can find the third one. So angle B is going to be 180 degrees minus the sum of the other two being 50 degrees plus 30 degrees. So you add those together, you get 180 minus 50 plus 30, which is 80. So angle B is going to be 100 degrees. Okay? Now, after this, it's your choice on how you want to find those missing side lengths. You'll notice the only side length you do have is side length A. So I'm going to be using sine of A over A for sure to set up one of my pieces of my proportion. And then I'm just going to go ahead and solve for the angle that I did know, which was C. So I'm going to find this side length C next. But it doesn't matter. You could find your side length B if you wanted to. So the sine of angle C over side length C. So that's going to be the sine of 50 degrees over 10, right? That's my given stuff, equals the sine of 30 degrees over my side length C. Now this is a proportion, so I will be cross multiplying. So C times the sine of 50 degrees equals 10 times the sine of 30 degrees. So to get C by itself, I'm going to divide both sides by that sine of 50 degrees. So this is what I'll be typing into my calculator to find side length C. All right, and it does say to round to the nearest tenth. So I'm going to go to my calculator and make sure that when you do this, since you'll be most likely using Desmos, all right, but whatever calculator you are using, always click the wrench and make sure you're in degrees, right? If you start with opening Desmos, it's going to default to radians, so make sure you head to degrees or click degrees. So I'm going to type in 10 times the sine, so 10 times the sine of 30 degrees over the sine of 50 degrees. So this is going to be approximately my side length for that missing piece that I just found, all right, which is going to be 6.5 rounded to the nearest tenth. So C is approximately 6.5 units. Okay, now we have almost everything, right? This is C. So now my last thing to find is side length B. And since you have options, you can use whatever you want. What I tell students is, my general rule from high school math is to wait until the last possible moment to round. That's going to be broken a lot in this lesson, and that's okay. I'm giving you permission to break that rule. But if you can avoid it, avoid using rounded values if possible. So what I mean by that is, let's go ahead and just use the sine of A over A again. And then we'll use that to help us find side length B, okay? So this is going to be the same. Sine of 50 degrees over 10 equals the sine of 100 degrees over B. Cross multiply. You're going to see the process is almost identical. We're just changing the numbers. So B is going to be equal to 10 times the sine of 100 degrees over the sine of 50 degrees. Again, we're going to round to the nearest tenth. So go to your calculator. All right, we have 10 times the sine of 100. So I can actually just copy and paste this. All right, but this is going to be 100 in the top. So approximately 12.9 units for side length B. All right, so 12.9. And that's it. That's how we're using the law of sines to solve for the missing pieces, angles, side lengths in this triangle. All right, let's do another one. Okay, now in this one, it's the same thing. I'm given 2 out of 3 angles. So if I'm given 2 out of 3 angles, I have angle A. I don't know angle B, but I do know angle C. I'm going to go ahead and solve for angle B, that missing one, which is 180 degrees minus the sum of 98 degrees plus 43 degrees. So when I add that together, that's going to be, 100 plus 45 is 145, take away 4, so 141. So angle B is going to be 39 degrees. Okay. Now, I know side length B, which is 22, and that's the only side length I know. So when I set up my first law of sines proportion, I'm going to be using sine of B over B, all right, because I don't know any other side length, and I must know at least one side length to do this. So now you got choices here. You can solve for your side length A, solve for your side length C. Doesn't matter. I'm going to solve for side length A next, but again, it really doesn't matter. So the sine of 39 degrees over 22 equals the sine of angle A, which is 98 degrees, over side length A. Cross multiply. And then don't forget to divide both sides by the sine of 39 degrees. All right, so this will give us our side length value for A. So I have 22 times the sine of 98 degrees. 22 times the sine of 98 degrees, all over the sine of 39 degrees. So approximately 34.6 units for our side length A. So 34.6. All right, now do the same thing. I'm going to use the sine of B over B again, but this time I'll be using sine of C over C. And if you did it the other way, it's again, I don't really care, right? It's your choice. Now, you'll notice that I'm not using the sine of A over A to find the sine of C over, to find side length C. Again, if I can avoid it, right, I'm trying to avoid using rounded values, right? And this answer down here is rounded, so I'm trying to avoid using that in another equation if possible. So the sine of 39 degrees over 22, remember, none of that's rounded, equals the sine of angle C, which is 43 degrees, over side length C. Cross multiply. All right, and then divide both sides by the sine of 39 degrees. And we will get our answer. So the denominator is the same, but the numerator is 22 times the sine of 43 degrees. So the numerator is 43 degrees. All right, so 23.8 approximately. 23.8. All right, so that's it for this one. All right, now I've got two more examples to do, and the reason I've got two more is that you're thinking like, I've like, hopefully you're watching this thing like, I can definitely do this. You definitely can. But the reason I've got two more is because now we're going to talk about what happens if they don't give you two angles. All right, so you'll see in this next one and the one after, we're only given one of the angles. So here's angle A, which we know. We don't know angle B. We don't know angle C, right? So this is side length A, side length B, and I don't know side length C as well. All right, so you have to use, right, in this case, you're going to see we have to use the sine of A over A because we actually know both of those. And then if I tried to use the sine of C over C, I don't know angle C, right? I don't know angle C, and I don't know side length C, so I can't use that at all. So I must use the sine of B over B. And this is going to be one of those where it's going to try to mess you up. But I'll show you kind of what happens with this one. So we got the sine of A, which is going to be sine of 35 degrees over side length A, which is 6. The sine of B, which I don't know angle B, over side length B, which is 8. So you cross multiply and you get 6 times the sine of B equals 8 times the sine of 35 degrees. All right, so I'm going to divide and get 8 times the sine of 35 degrees over 6. But watch this, guys. You'll notice that now I'm trying to find this capital letter B, which is an angle. So actually, to find angle B in the calculator, I do sine to the negative first power of 8 times the sine of 35 degrees over 6. So I'm actually going to tell it to go backwards to find that angle B. All right? So I'm going to have sine, I'll delete this, I guess, sine to the negative first power of, and my fraction, which is going to be 8 times the sine of 35 degrees over 6. I believe that's right. Excuse me. Yes. Okay. So round it to the nearest tenth. Just confirm it says to the nearest tenth. It does. So round to the nearest tenth is 49.9 degrees. 49.9 degrees. All right. So now I know angle, or excuse me, let me hold on one second. So we got 49. I almost made that mistake. We got 49.9, but look at the sketch. Do you see this angle here? This angle is obtuse, right? It's greater than 90 degrees. So actually, to find angle B, I'm going to be doing 180 degrees minus 49.9 degrees. So that's one of those where if you do that, you'll make a mistake. So just be careful. Look at the sketch. If it's obtuse, we need to actually subtract it from 180. So 180 minus 49.9 will actually give us our angle B, 130.1 degrees. All right, so this is 130.1 degrees. So now we can find angle C, which is going to be 180 degrees minus the sum of the other two. Oops, sorry. 130.1 plus 35 degrees. All right, so go to the calculator for that. So we've got 180 minus the sum of the other ones, 35 plus 130.1. This is 14.9 degrees. All right, so that's C. All right, so that's one way they'll try to mess you up with doing this. So now, all right, again, if you can avoid it, avoid using rounded ones. And so I'm going to avoid using my sine of B over B. So I'm going to go back to sine of A over A, since none of that is rounded, and use sine of C over C to find my last piece, which is my side length C. So sine of 35 degrees over 6 equals the sine of 14.9 degrees. And I understand that that's rounded, so sometimes you can't avoid it. Cross multiply. and then we'll divide by the sine of 35 degrees. And that will give us our side length C. All right, so we've got 6 times the sine of 14.9. So 6 times the sine of 14.9 over the sine of 35 degrees. All right, so 2.7 approximately. All right, and that's it. That's how to find the missing pieces with that little bit of a twist where we didn't know 2 out of 3 of the angles, so we had to find an angle first. And then from there, we had to make sure we didn't get caught that this right down here, right, this is not the actual angle B. We use that to find the actual angle B. Okay, let's do one more and then we'll be done. All right, so same process here. I only know one angle, so I've got to use that one. So this is the sine of angle C over C. Here's A, here's B. And I know side length C, I know side length B, so I'll be using sine of B over B. All right, so we have the sine of 85 degrees over 12 equals the sine of, I don't know angle B, over 9. You'll notice I don't know side length A, I don't know angle A, so I can't use that at all yet. I will get there. Cross multiply, so 12 times the sine of B equals 9 times the sine of 85 degrees. Divide by 12. And then finally, because I want to find an angle, I've got to go backwards. Sine to the negative first power of 9 times the sine of 85 degrees over 12. All right, so let's go to the calculators to do that. 9 times the sine of 85 degrees. So sine to the negative first power times 9 times the sine of 85. Make sure I got that right. Over 12. And we get 48.3. And I look at my sketch, right? This is 48.3 degrees. And I look at my sketch, and my sketch for angle B here is not obtuse, right? It's not greater than 90, so I'm okay with 48.3 degrees there. So now I can use that to find my missing angle A. So angle A is going to be 180 degrees minus the sum of the other two angles. So 85 degrees plus 48.3 degrees. So let's add those together. So 180 minus 85 plus 48.3. Make sure I got that right. 85. Yep. So 46.7 is angle A. 46.7. And now I can use my sine of C over C equals sine of A over A to find my last side length. Again, I know it's unavoidable here, but try your best not to use rounded values if you don't have to. In this case, I did have to use a rounded value for that angle A. So I'm cross multiply. A times the sine of 85 degrees equals 12 times the sine of 46.7 degrees, and divide by that sine of 85 degrees, and then we will be all finished. All right, so we have 12. So 12 times the sine of 46.7, I think, let me confirm, divided by the sine of 85 degrees, which is approximately 8.8. All right, and that is our side length A. And that's it. So those are kind of the variations you're looking for when you do the law of sines.